Hey there, Terry Caliendo, Dedicated Managers, back again for some more understanding of the OAuth 2.0 IETF RFC 6749. That's a lot to say. We're talking directly from the IETF. I had trouble reading the RFC, and so that's why I'm doing this series, to help anyone else that might have some struggles with understanding the actual RFC. So last we talked about was section 1.5, the refresh token. And now we're going to move on to, I'm going to skip 6, 7, 8, and 9. Those aren't really big deals. I mean, yeah, you're going to use HTTPS and you're going to do redirects and certain things, but that's pretty obvious stuff. Next stuff we're going to jump down to is 2.1 here, client types. So there's two types of client types, and again, I need to bring this back to so we can understand where we are and what we're talking about. And I got to jump ahead to do that, unfortunately. But if I open this in a new tab here, and we look at this, this is the flow that we'll talk about at some point soon, hopefully, for the code grant as opposed to the implicit grant. But you can see the different players in the game here: the resource owner, the user agent, the client, and the authorization server. So what we're talking about here is the client type. Now, this client type varies based on what type of application and where that application is going to be located. So if you're coming from, you're trying to use this OAuth 2.0 from like an iOS app or an Android app, you're going to have a different look at this than if you're coming at it from a front-end WebJS app. So that's what we're going to talk about, this client here. And this is what really threw me when I first started reading this, is I just didn't understand these pieces. I thought the user agent, since I was doing a VueJS application, I thought the user agent was the VueJS application. Turns out down here is where the VueJS application is. So that's what we're going to talk about right now. So let's skip back down to the client type here. And so there's two types of client types. There's confidential and public. And confidential is considered something that's capable of maintaining the confidentiality of the credentials. So if you give it a secret or a token, is it hackable? Can somebody easily, an end user who might be an actual hacker, can they get at your code and whatnot? And as far as we're concerned here, the confidential one, the confidential client type is someone where it's for the most part, extremely difficult for someone to get a hold of your credentials, whether it's a password that you store, a secret key that you store, or the tokens that you might receive. That stuff can be kept private, and that's pretty much done on a client implemented on a secure server with restricted access to the client. So, on the other end of that, or let's just say that this right here, this confidential type, is for the most part a traditional PHP application. If you run, WordPress typical currently, you make a call for a web page. WordPress runs in PHP, creates the web page, and sends the HTML output back to the user. So let's talk about that in this diagram here. The resource owner is the person that's trying to get the website. So in a typical WordPress application, that a public website, that's not going to be protective. But say we're in the members section of the WordPress where a person has to log in. So that's the resource owner, where they're going to log in with their credentials, and the user agent, therefore, is going to be the web browser, which is this thing that I'm pointing to right here as a web browser, right? And the client is then going to be the server-side PHP application, and that is running completely on the server. So that thing can make calls using keys and codes and whatever it needs to back to the authorization server and receive client, secret information back, render the web page, and then send it back to the user agent, which is the web browser, and that this resource owner the resource owner ends here. The resource owner can't get into the server; it just receives a web page back. So that's where we're talking about this client being confidential. The code is running somewhere that this resource owner or a potential hacker acting as the resource owner can't get at the client. And then as far as public goes, now this is where we start talking about VueJS or ReactJS. And so clients executing on the device used by the resource owner, such as an installed native application, which would be an iOS application or an Android application, or a web browser-based application. So that's going to be the VueJS or the ReactJS or any of those JavaScript front-end frameworks are going to be browser-based applications. So let's talk about this diagram in that respect. So as far as a front-end VueJS application, the user agent is still a web browser. The resource owner is still the person trying to access the information or the person who could be the hacker. But the client here, this code is now running in the user agent. It's JavaScript code running in the user agent. This isn't a back-end server anymore. This client is now part of this user agent. And it can easily be, the code can easily be seen and extracted from the browser. So if I right-click, if I go here to Dedicated Managers and I right-click to inspect, and I go to my network tab, if I go to the application tab and I look at local storage, there's nothing locally stored there, but we can go to session storage and see if we can see some cookies. Cookies here. And so, there's cookies here. So I can actually extract the cookies. So if you save a token or a secret in a cookie on a web browser, a hacker, somebody that walks up to a person that's maybe logged in already or, has hacker access, remote access to the screen, can pull that information somehow, or maybe if they can, somehow get into the machine, they can pull that information. Whereas in the server, what we talked about before, they'd have to hack the server, which is kind of a different case. This is less protected because it's on somebody's browser in their computer. So the resource owner could be a hacker that takes their token and tries to exchange it with somebody else's. It's more access. So back to the drawing here. This client, as I said, in a front-end JavaScript application that might want to log someone in, it's running in the user agent. The code is there. It's reverse engineerable. You have to give the code to the user agent for it to run because it's a real-time JavaScript runtime on the browser. The other thing is for the public client is the native applications. So if you are creating an iOS application or a Android application that's going to run on on an iPhone or an Android, so now the resource owner is the same person. The user agent is now the phone. It's either the iPhone or the Android phone. And the client is now the native application code that's downloaded as an app onto the phone. So the client, it's still considered a public client because the code is reverse engineerable. The code is being sent to something that the resource owner has easy access to. This code is showing up on the phone. The resource owner can plug their phone into a computer and extract that code and take a look at it, reverse engineer it, put it into a hex viewer or something that can reverse engineer code and actually pull out secrets or passwords if they're hard coded in them. If you search YouTube for videos on security cameras that have hard coded backdoor passwords in them it's just super easy for hackers. Most home cameras have stupid stuff like this that hackers can easily get extract passwords from code. That's different from this authorization service. I'm just saying that I'm showing that trying to state that the code that's on the phone is, even though it's compiled into a binary file, it's still reverse engineerable and you can pull strings out of it. So that's why the native application is still considered a public client, because it can be reverse engineered. So hopefully I've explained that pretty well. The two different client types, that's going to come up later as we walk through the different flows. And then there's some more paragraphs here. The client, the client type designation is based on the authorization server's definition of a secure authentication. So the way I interpret this, if you wanted to, if your authorization server wanted to consider a native application a confidential, it could. That's not typically what people do, but that's the way I interpret this paragraph, that it's up to the authorization server to decide that. So if you're using something like Auth0, Auth0 has decided that these other things are going to be public, and the server is going to be the confidential. Then I'm not real strong on this paragraph here. This paragraph is talking about multiple distributed clients that contain a confidential and a public-based component, and it's saying how to treat that. And if the authorization server does not provide support for such clients, or does not provide guidance with regard to the registration, the client should register the component as a separate client. So the public part should register as a public, and the confidential part should register as a confidential. And then this part down here goes back to define the things I've already defined, what a web application is. So a web application is considered the server-side application, like the WordPress that I was talking about, the PHP, where the HTML is rendered on the server before being sent back to the user. Resource owners access the client by an HTML user interface. That's the web browser. The access token is issued to the client and stored on the web server. So the PHP code would interact with the PHP code here is on the server. It interacts with the authorization server to get a token. That token sits on the server and is not sent. The web page is then rendered and sent to the user agent. The user agent that's accessible to the resource owner is not receiving the token, so that token is considered held safe back there, confidential. A user agent-based application, that's going to be your web browser-based application, which is going to be a JavaScript front-end type deal. And so the protocol data and credentials are going to be easily accessible. You can right-click, choose inspect, and then go to the network, see what was downloaded, and reverse engineer the code. You can actually see any JavaScript code. If I look here on dedicated managers here, and I go to network, I have to refresh it to get some code to come. But I can start looking into here and looking at the response and start looking at all the code. And if there's some JavaScript that comes through, like this jQuery, see, I can see code, and anything that's got a string in it, I can see strings. So if you put the token as a string there, it's anywhere in the data, even if it's in memory, it can be retrieved. So it's considered a public type agent. Same with the native applications. They are considered public, as I said before. It is assumed that any client authentication credentials included in the application can be extracted, so that can be reverse engineered. We'll talk about it later. There's a different flow. There's a hybrid flow you can use for a native application that you can't use for a browser-based application. And so, yeah, that's pretty much it. Those are the three major applications. Those are the three types of clients who, if you're a programmer, you're probably writing that client. And so those are the three different types, or the three different avenues you might be coming to the RFC 6749. You might be coming to the OAuth 2.0 framework to look at. So that's the end of this video. Hopefully that 14 minutes, it was a good long one. I talked for a while. Hopefully understood, kind of where things were coming from. Again, Terry Caliendo, dedicated managers. This is the YouTube playlist here that I'm currently working on. Please subscribe. Come to the dedicated managers page there, hit subscribe. I got 392. I was happy to get 100. Now I'm going to be happy to get 1,000. Looking to have another party at 1,000. So thanks again for listening. Hope you enjoyed this. Take care. Have a great day, and happy programming.